All right, let's get right into it. We're going to trace the life of one of nature's most incredible and, honestly, misunderstood forces, the tsunami. It's a fascinating story that starts way down in the dark, silent depths of the ocean and ends with unbelievable power, sometimes thousands of miles away. And that brings us to the biggest puzzle about tsunamis, right? I mean, think about it. Out in the open ocean, a huge ship could sail right over a tsunami and the crew wouldn't feel a thing. The wave itself might be less than a meter high. So how on earth does that little ripple turn into a catastrophic wall of water? Well, that's the mystery we're going to solve today. You see, the whole story starts where no one can see it. We're talking miles below the surface, in the crushing pressure and total darkness of the deep sea. This is where the seed of a tsunami gets planted, long before it ever feels the sun. And it almost always begins in a very specific place, called a subduction zone. The easiest way to picture this is to think of the Earth's crust as a giant, cracked eggshell. These zones are where two of those massive pieces, the tectonic plates, are crashing into each other, and one is literally being forced down and under the other. You can just imagine the insane amount of tension that builds up there. Now, that tension, that pressure, it can't just build up forever. Something has to give. And when it finally does, it's in the form of a gigantic undersea earthquake. That's the trigger. That's what kicks this whole thing off. So let's walk through exactly how this trigger gets pulled. First, the plates are grinding against each other, but friction causes them to get stuck. They lock up. For years, sometimes for hundreds of years, the stress just builds and builds. It's kind of like bending a plastic ruler. You keep bending it, and you just know it's going to snap. And then boom, the plates suddenly slip. All that stored up energy is released in one violent instant. That's your earthquake. Okay, so the earthquake happens, but how does the energy from shifting rock transfer into trillions of gallons of water? That moment of transfer, that's the birth of the tsunami. It's the critical link in the chain. The secret ingredient here is something called vertical displacement. It's really just a technical way of saying the seafloor has to move up or down, not just side to side. Picture a massive chunk of the ocean floor suddenly shooting upwards. It acts like a colossal paddle, shoving the entire column of water from the very bottom all the way to the surface, straight up. And this is exactly why not every earthquake under the sea kicks off a tsunami. You really need two things. First, it's got to be a big one. We're talking a magnitude over 7.0. And second, you absolutely need that vertical movement. If the plates just slide past each other horizontally, they just stir the water. They don't lift it, and you don't get a tsunami. So our wave is born, and it does not waste any time. With all the power of a megaquake behind it, it starts blazing a path across the open ocean like a high-speed train. Now get a load of this. In the deep ocean, a tsunami travels at about 800 kilometers per hour. That is literally the cruising speed of a jet airliner. I mean, it can cross the entire Pacific Ocean in less than a day. It's just terrifyingly efficient. But, and here's that paradox again, for all of its incredible speed, a tsunami in deep water is basically a ghost. Its wave height is tiny, maybe a meter at most. The real energy is hidden in its wavelength, which is the distance between the peaks of the wave. That can be over 100 kilometers long. The energy is so spread out, it's practically invisible. It just slides right under ships and no one's the wiser. Okay, so this high-speed ghost has just crossed the entire ocean. But as it gets closer to land, as the seafloor starts to rise up to meet it, everything is about to change. This is where the wave begins its terrifying transformation. And there's a name for this process. It's called wave shoaling. Shoaling just means moving into shallower water. And as our wave does this, it completely changes its character. This is the answer to our mystery. Let's see how that low, fast wave becomes a monster. This chart breaks it all down. As the water gets shallower, the bottom of the wave starts to drag on the seafloor. This slows the wave down. But all of that energy from its speed and its super long wavelength has to go somewhere, right? It can't just disappear. So the energy compresses. The wavelength gets shorter, and all that forward energy is forced upwards, causing the wave's height to grow and grow and grow. This is the moment the hidden threat finally rears its head. So the wave has finished its transformation, it's arrived at the coast. This is the final, most destructive part of a tsunami's life, where all that deep ocean energy is finally unleashed. And here is a really critical and often tragic point. A tsunami is almost never just one wave. It's what's called a wave train, a whole series of waves that can keep coming for hours. And what's so dangerous is that the first wave isn't always the biggest. People might survive the first one and think it's over, only for an even larger wave to hit later. And the destruction it causes is just mind-boggling. You've got the flooding, of course, but it's also the immense force of the water, which can smash buildings to pieces. Then you have all the debris, cars, trees, parts of houses that get turned into battering rams. And even when the water pulls back, it's not over. The long-term damage, like contaminated water supplies and a completely disrupted environment, can last for years. And this quote really brings it all back home. This isn't just some abstract science experiment. It's a very real and constant threat in places like the Pacific's Ring of Fire, which is just loaded with the subduction zones we talked about. The potential for these events is always there. So, now we get it. We followed the journey from a silent slip deep in the ocean, all the way to a wave's final, powerful transformation. But this understanding leads to a much bigger question, doesn't it? Especially as sea levels rise around the world. We know how they work, but are we truly prepared for what's next? That's definitely something to think about.